I'd like to start by thanking everyone for joining us today for our debut presentation of Down to Earth. My name is Matt Rosenbaum, and I'm the sales manager for the Southern United States for Microdrones. Joining me today is Nick Tucker. He's the Vice President of Energy Services for Crafton Tull. How you doing today, Nick?
Good, Matt.
Good, man. Good to have you. Along with Nick, we got Jeff Davis. He's the survey coordinator and UAV pilot for Crafton Tull. Hey, Jeff, how you doing, buddy?
Doing good, man. How are you?
Good, man. And finally, we got Ross Kinney, who's the sales UAS sales and support representative for NEI. He's here to offer some valuable feedback as well. Hey, Ross, how you doing, man?
I'm doing good. Glad to be here with you guys.
Together, Nick, Jeff, and I were the co-stars for the first 3 episodes of Down to Earth, which is a reality-style documentary that captures the challenges professional surveyors face when in the field. They're not always out in the office. Sometimes they actually get out in the field and do some work out there. So once you kind of dive into this video, you'll see when it's all said and done, we weren't really the co-stars. The data that was gathered from the drone really was, and how it gets collected and processed and finally visualized, which ensures a job well done and another satisfied customer for Crafton Tull. Hey, Nick, would you go ahead and pull the data up so you can kind of give a brief description of the project and they can kind of see what we were up against out in the field in the Ozarks?
Sure. Okay, so quick project overview for this. The project scope was about 160 acres of timberland up in the Ozark Mountains. The client wanted to essentially build a road from the actual county road at the top of the hill down to the river itself, so that he can build a cabin and have direct access from the road. So the project manager asked me, if we thought that we could fly it with the drone or the UAV instead of actually shooting it with GPS. And of course, I jumped on the opportunity to be able to do this. And so that's just kind of the overview of what we were going to do. Was essentially just try to fly this 160 acres and find the best path for a road. I mean, as you can see on Matt's screen here, this is what we were looking at in the office. You can see that obviously there is a lot of hills, a lot of mountains in the area, but the terrain change and the magnitude of that really doesn't get put into perspective until you actually get on site.
Absolutely. No, as you can see, it's kind of tough to see within the Google Earth file, but you can start to see some sheer cliffs just from how the 3D view in Google Earth does show. And that band runs all along the edge of this property. So when we got out there, we kind of did, Nick, Jeff, and I did some initial planning, before we even arrived on site with the KML in MD Cockpit, which we'll hop into right now. So MD Cockpit is the flight planning software that you use to plan missions with the Microdrones solutions. In this case, it's run on an Android tablet. In here, I actually have the project pulled up. So if I open up MD Cockpit here, you can see, similar to what we were looking at in Google Earth. It's about 160 acres, and the only vantage point that we even knew about on site, right, guys, was this bird's eye look. You kind of overlook that you can see over here on the east side. So we knew we were going to have to fly this project in that way, and that was where we actually set to take off the first time. We utilized the terrain following feature, which uses the SRTM model in the background of MD Cockpit. So after you actually plan a takeoff waypoint, you can see these selections come about on top of the screen. So when we click terrain follow, we can actually use one of the features called the export to KML feature. We can actually view the flight plan in Google Earth. But before we actually get to that point, some other things is just kind of to look at from the project. For this 160 acres, it looks like, at the height and speed that we decided to fly at, which I believe was at about 4 meters a second. It says this is going to take about 86 minutes. So initially, Nick, Jeff, and I thought, about 5 to 7 flights, we could probably get this, knowing that the drone was going to waste some more battery following the terrain. But, quickly as we got out there, we started to learn a little bit more about the project. And you could see after we exported the KML and viewed it in Google Earth, we started to get a better picture of what that looked like on site. So if I open up Google Earth, Here we have again, can everybody see Google Earth?
Yep.
So here is the initial flight plan that we did before we actually got on site. So you can see, quite a few flight lines. It was going to take, about 33 strips to cover this whole entire project, staying about 50 meters above the ground. But when you really start to get into 3D view, you can start to see, how the drone is actually going to be flying in this case. So what you'll see when you actually get into the video, we were a good ways away from the actual flight block itself. And you can see, when we actually got to the beginning of the project, we noticed, we knew we were going to run into some issues with battery life just because how far we were flying and how the drone was actually handling the terrain. But it really came to life as we got out there and learned more on the fly. Hey, Jeff, do you have anything more to add, about the project?
Yeah, man. Kind of like what you were talking about. One of the main challenges we ran into was limited areas to stage from. So not a lot of options as far as takeoff and landing. So, like you talked about having to send it 3,000 feet away. We knew that was going to be an issue. And then another one that really concerned me was going to be like the depth perception. As the drone gets out there up against the horizon and you can't really tell. Is it close to those trees? Is it not? And So yeah, that was another major challenge.
Yeah, for sure. Like the not being able to stage anywhere, that was, a good place to visualize the drone flying. It was tough with all the terrain changes, 100-foot tall trees everywhere. That was definitely probably the biggest challenge we had out there. Let's see what all the hype's all about, and let's get into episode 1.
Big Creek River carves a winding path through the Ozark Mountains in northern Arkansas, flowing through steep bluffs, treacherous ridges, and challenging terrain. It's here that engineering and surveying company Crafton Tull has been tasked with surveying 150 acres to collect data needed to design a new road through the heart of these rocky cliffs. Upon reviewing the project, Crafton Tull team members Nick and Jeff have determined that using UAV LiDAR technology to survey the area will generate the point cloud visualizations needed to complete their mission. However, the mountainous terrain, remote location, and scale of the project presents one of the most challenging surveys the Crafton Tull team has ever experienced.
So our goal today was to get out here, get a feel for what we're up against, plan some flights, and hopefully get a few flights completed today.
Crafton Tull has selected the Microdrones MD LiDAR 1000 to survey the terrain. For most jobs, Nick and Jeff can use their UAV technology to easily create their plan, fly the area, and then process and visualize the data into a 3D point cloud. However, here in the mountains of the Ozarks, they are faced with over 500 feet of elevation change over a large area of challenging terrain. For this mission, they will need to set the height above ground level at 50 to 60 meters to accurately collect the laser scanning from the LiDAR. It will take meticulous planning to keep the drone a safe distance from the steep cliff edges and treetops, while still getting the data they need.
Just on that side of that big bluff right there is where we're going to start, up there at the top of the hill. And it's closest to us that way, and so if something looks wrong, we can kick it out and bring it back. So we need to get the base up and running next. So, typical procedure is just to set a point on the job. We'll bring in a here position, which is like an autonomous GPS position, similar to what your phone would pull in. We'll get a corrected position so that it's right with where it's at on the earth.
Without the drone, with the regular survey crew out here, you're looking at probably 2 to 3 weeks worth of field work to get this surveyed. It's dangerous too, because there's some sheer bluffs on here that would be really challenging to get data on.
And the challenge on this project is the terrain. From surveying to the top of the mountain to the bottom of the mountain presents a great challenge.
You have to monitor, because it's going to lose battery more because of how it's flying.
I don't think that we'll get more than 2 flight lines with the terrain follow, you're right.
I don't think so either.
But to fly it manually is going to be so difficult.
We could also move the takeoff point to closer to the front, so we could just fly it, take it off here, manually fly it over there. I'm just here really to support the guys from Crafton Tull. I always like to kind of see what kind of projects they're using our systems to do. This one is obviously putting everything to the test, and it's kind of neat to see how we tackle this.
We're topping the batteries off. As soon as the batteries get topped off, we're gonna get set up and put the bird in the air, get to some action.
Jeez. You have enough battery too?
I mean, we pretty much burnt the entire battery just getting there. The problem is depth perception and where you're actually at. You can see it on the map, and when you get down there 3,000 foot away in the bottom of that, you have no idea. Dang.
With the difficult terrain, we ended up using a lot more battery than we thought, just getting to the flight block.
We weren't able to capture any data due to the amount of battery that was used in the elevation change.
We're gonna have to think this one out for sure.
I'm throwing the challenge flag and calling it audible. So according to Randy, from that ridge line right there, that bluff, that furthest one on that point that you can see, back to here, there is 0 chance of going off any of that bluff line with a road. He has got a place where he's gone and found a little bit of a gap. It's got like a 15 or a 20 foot drop versus 100, and you can't see that from here. So we may need to just retool, pick up, go over to the lodge area over there and set up there, develop a plan to really focus in on the valley and capture that valley down there, and then we'll run one corridor line back and forth where he thinks, because Randy's walked this entire property. And so now that Randy's discovered this best place to go off, most efficient place, we need to focus our energy there.
Perfect.
After doing some scouting and talking to the local land manager, Randy, we realized that the only feasible location was one specific spot. And so Randy showed us that spot, and it dramatically reduced our project area or our project limits.
Oh, I've lived here all my life, and I'm 59 years old. I'm caretaker of this, a couple of properties here, and I mow the yards and everything, keep maintenance done on them.
All right, so what we're gonna do is we're gonna pick up and punt and go to the other side.
With the lower part of the bluff, there's not a very good place for us to see the drone, so we're gonna have to find a better vantage point tomorrow to make sure we can see the drone throughout the flight and complete this last part of the mission safely. Talk about some high drama there, guys. There's a lot going on in that staging area day one. Let's kind of talk a little bit more about what happened. Nick and Jeff, you want to kind of hit on a couple more of the challenges that we ran into out there?
Well, so, like I stated earlier, we had an initial flight plan. We really only had one spot to take off and land from for that particular project or what we thought on that project. And as you can see in that episode, there was some high drama when we took off and took off towards our first waypoint. It was kind of nerve-wracking for the first flight, and then once the drone actually got out about 3,000 foot away from Jeff and I, the depth perception really kind of played a part in our nerves. You really couldn't even tell whether it was going to hit the trees or not. To be honest with you, I try to lean on Jeff as much as possible whenever we're flying, to get live feedback. As if I'm watching the controller, he's watching the drone, or vice versa. And you really just couldn't tell how high it was looking at the screen or even looking at the drone across the valley.
Just to bring the viewers up to speed on how, what's going on with the flight plan and everything in the background. So the drone's actually using, it's called the SRTM, but it's essentially a very broad, very wide, you can call it a LiDAR file, but it's really radar from the shuttle. But it's a point about every 100 feet or so on the ground. So the way we actually designed the mission at first, it was actually going to follow the terrain going up and down the mountain, which we learned probably wasn't the most efficient way to do it, because especially with how steep the terrain was. It works great for, some with, rolling terrain, but when you have, a 6-to-1 slope like we did here on this site, every 100 feet, you might have 75, 100 foot of elevation change. So the drone is going to kind of stair step up the mountain, and it's just not the most efficient way to plan the flight, which we learned quickly. Thankfully, Randy came and saved us and said, I don't know why you're trying to survey this whole project. The only place you can build a road is over on the other side of the project. And that's where we kind of left off from the video that you saw. Jeff, do you want to kind of bring everybody up to speed on what we did behind the scenes to actually plan those next couple flights and what the Crafton Tull engineer and Randy did on site?
Yeah, so Greg, our engineer, arrived on site, and then he and Randy walked the route that Randy thought was the best case for the road, and then Greg he created some waypoints for us while he was walking the route, and from there that's how we built our flight blocks. It was off what they captured on their reconnaissance, if you will.
So what ended up happening is after Greg and Randy walked that route, they exported a KML out for us, and we used that KML to actually build a corridor mission of the proposed road. So we were actually focusing all of our efforts on the only place on this whole project where a road could potentially be built. I mean, if you remember, we were taking off from way over here, and this was our first flight line, which is going to cover on this side. Now we're down on the far west side of the project, running a corridor mission from the top of the project down to the bottom. And we built the mission from the KML, set our parameters. I think we wanted to make sure we covered about 150 feet on either side. So our corridor is that wide. Our mission is that much coverage. So we can set that in within here. And after we were done with that, we exported out that KML so we could view it in Google Earth like we did with the first one, which I'll open real quick. This is the mission that we actually ended up flying for the most part. So if you notice, we actually took off from, there's a cabin that we kind of staged at that was in this general area over here. We actually ended up breaking this into 3 different flights. So if you notice, there's a nice gradual elevation change from the road to the cliff, probably 150 feet or so, right, Jeff? If I remember right, about 150 feet from the road down to the cliffs. Then at this area right here, there's probably about 200 feet of elevation change, probably 300 feet from this point to this point. So we knew we were going to have to get kind of creative in order to fly that portion. And then lastly, we had the bottom third of the project down where the house would eventually be built near the big creek. So we ended up breaking it into 3 flights. This top portion here, we had the cliff, the bluff, and then finally the bottom third. And we actually ended up flying one more just to ensure we got all the data we needed on the project. Would y'all like to add anything?
So guys, I'd like to ask a quick question to Nick and Jeff. If you were to try to do this project without a drone, how much more difficult would it have been, and how much longer do you think it might have taken you?
Yeah, I mean, as we kind of stated earlier, Jeff and I, estimated that a 2-man crew would probably take 2 to 3 weeks to topo the entire area. Now, even if they were just to narrow it down to the corridor that Matt showed on his screen that we ended up actually flying, I think it would probably take a 2-man crew at least a full day, probably 8 to 10 hours of actual labor time, but the resulting set of contours and data would not be near as dense and possibly not as accurate. It might even take 2 days because it was all in timber. So not to mention what Jeff had mentioned earlier, just the safety aspect of this. I think there were 2 bluffs. It's kind of hard to see in the Google Earth image, but there was one that was a sheer bluff of about 30 foot. and then a small ledge, and then another 50 to 60 foot sheer bluff. So there's 100 foot of elevation change and probably 100 foot of horizontal feet.
Easily. Hey guys, y'all ready to hop in to check out video 2? Episode 2?
Let's hit it.
Jeez. With the difficult terrain, we ended up using a lot more battery than we thought, just getting to the flat block.
We weren't able to capture any data due to the amount of battery that was used on the elevation change. All right, so what we're gonna do is we're gonna pick up and punt and go to the other side. So today is day 2 of the project. Day 1 presented several challenges with the terrain and just how we're going to approach the project. After getting through day 1 and getting some resolution to those conflicts, it really helped us plan a little bit better for day 2.
We learned a couple of things from yesterday, so hopefully today goes a little bit smoother. The first thing we want to do is we're gonna get down in the valley. We're going to take some GPS shots to check with our surface, and then after that we'll start making our flights.
The engineer is going to walk it with the property manager. He's going to take a handheld GPS and export me out a list of waypoints, and then we're going to fly that waypoint list as a corridor. So we're going to essentially take a 160-acre flight project and probably condense it down to about 20. And then we're just really going to key in on the areas where we know we can actually build. There is miles and miles of ATV trails. We took off at the top of the hill, rode down probably 3 or 4 miles, drove through a couple of feet of water, did a little bit of mudding, all that just to get to the actual project site.
After we collect all the data with the LiDAR, we'll take it back and we'll create a surface over the area that we've flown. And we'll take these GPS shots and we'll compare them to the surface that the LiDAR created. And it's just an accuracy check. Make sure our data's good. Right, that'll do it for here.
We're going to verify the data from the last flight that we just flew and make sure that we've got enough data for the entire project. That's just going to help us determine whether we need to fly again. So that's the gap, all that right there. The ground data stops right there. Like all this right here is going to classify as ground if I don't get something below it.
Yeah.
See, that's for the day, right? And then you turn on yesterday, as you can see where the gap is. This is all unprocessed data too.
Yeah.
So is it going to put a shift on it when I process it?
Let's fly that gap.
Why don't I do this? Let me trace that area and then export out of KML. I'll email it to everybody.
Yep.
So we've looked at the last flight compared to yesterday's flights, and we've got a little bit of gap in the data from just around where the bluff is. And so what we're going to do is we're going to create a small flight block and manually fly the bluff area to try to pick up some more data on that, and that should be everything that we need. Okay, y'all ready?
We'll probably have one more flight after this and do over the bluff. We have about a 12-minute flight. It's going to do a route at the bottom part of the mountain and fly all the way up to the bluff and then turn around and come back and scan the rest of the other side of the mountain for that proposed road corridor. So being in the field and driving four-wheelers and seeing this beautiful property is awesome.
Oh God. We got a flat. Just slammed into a rock going over the water.
Yeah.
You felt the whole thing jolt.
Oh, really? Yeah.
From everything that we kind of just saw, what I know I kind of spoke a little bit while everything was going on, but y'all want to kind of add, some of the techniques that you guys use and when you are out in the field, and how you make sure how you set up your projects, and kind of add a little bit more about the surveying side of things, and what you guys did in the background to make sure that you gathered the most accurate data possible.
Yeah, so before we fly or after we fly, we take our GPS and we get ground shots on the actual ground, and that way, once we get our point cloud created, and we run a ground extraction on our point cloud, and then from that ground extraction, we create a surface model, which we believe to be ground, as according to the LiDAR survey. Then we take that surface model and we compare it to our GPS shots, which we know are actually ground, and then hopefully they're within a few hundreds between our GPS and our surface model. So that's something we always do is on a project is we scatter GPS ground shots all throughout for accuracy.
Yeah, and if you noticed, we were all the way down to the bottom part of the project for these couple of flights in the video. We staged almost where the house is going to be built at the bottom part, and then flew that second flight from the creek bed all the way up to the essentially to the bluff side of the mountain. And if you notice in there, we had one more gap left, and that was essentially the data that was left over the bluff. So in this next video, you'll see kind of what Jeff and Nick decided to do in order to gather this data safely, because it was very challenging to actually see the drone on this last flight.
I want to ask one question. From one pilot to the next, Jeff, what made you feel like it was better to fly that bluff manually rather than just build another small mission to cover just that little gap?
So that was a group decision. We all three thought it would be best just to fly it manually, and just to kind of hit the area that we really knew we needed to hit, where we were missing data. And with just the extreme drop off right there, like Matt was saying, the DRTM, we're talking about 1 point every 100 feet, and just with the extreme drop off, we just felt it would be safer to manually stand on the bluff, and that way we can keep it a safe distance away from the edge of the bluff and a safe distance above the trees. So yeah, it was just kind of a group decision on that.
On this last episode, you'll see a little bit more in detail, and we'll talk about it as we go through it on why we thought that was the best decision, and really how we tackled it, and kind of some other snippets of what happened in the background from after this last flight. So without ruining anything, let's hop into episode 3.
Oh God. We got a flat. Just slammed into a rock going under the water. Yeah. And you felt the whole thing jolt.
Oh, really? Yeah.
Let's see if we can narrow it up.
Always prepared. Air compressor and a plug kit. There it is.
Well, I'll get in these and I'll get you up to where you're going so you can do what you need to do up there.
Okay. So we were literally 45 minutes away from the top of the hill from our trucks. We had to drive the other side-by-sides that we had back out, get a tire, and then attempt to actually change the flat in the woods.
You don't fit.
I don't know.
Negative.
Randy, who's the land manager out here, was with us and was gracious enough to drive back to the top of the hill, get a spare tire, bring it all the way back down to the bottom of the hill, only to realize that the spare tire was the wrong size and wouldn't fit the side-by-side.
Well, I mean, if the street gets up, I can't get back up here.
I know. So you got to try to deal with this today?
Yeah, I'm going to fix it today and get it back down there. Yeah.
Okay. All right, well, let's...
You don't have to mess with it. I got some girls I can bring down here and help get this back.
You sure?
You got to do, yes.
Okay.
And do what you got to do.
So getting the flat tire really didn't affect us. Thankful for us, we had a couple of extra side-by-sides to be able to track on to the project, and it really didn't take any time away from the project itself.
We're gonna launch it up real quick, and we're gonna go over there and actually stand on the bluff and manually fly it and get some more data on the bluff. So this should be the last flight, hopefully. Usually you put it in waypoint mode and you kind of just monitor the UAV and make sure it's doing what it's supposed to be doing, you know. But when you're flying it manually, you really got to be focused in on your telemetry and make sure it's flying where you want it to fly inside the flight block, and then it's flying the area you need to cover, because you're just kind of doing it on your own instead of the software doing it for you. All right, we're going.
This is the hands-on approach to manual flying right here. So right here where we're standing is on the edge of the actual project scope itself. The road is over here to my left. We're actually going to design the road to come down this hill, come off the bluff right here, switch back and turn down to the bottom side of the bluff, and then turn back again and then head towards the creek, which will be the bottom of the project. And so right now we're wrapping up our last flight line. This should get us all the data that we need. And he's done scanning now. So we're just gonna raise it back up to proper altitude and send it home and go get it. The challenge was we knew we weren't gonna be able to see the drone from where we took off. So when we did take off, we sent the drone to the flight block, put it in a holding pattern, walked through the woods to where we could actually spot the drone at the flight area. And then Jeff manually flew the bluff area with the drone, manually triggering the scanner to capture the data. And then we sent it back to the landing spot and then walked back through the woods to land the drone. We're bringing in the last flight now into the visualization software. So it looks like now that we've got all the data in the software, it looks like we've got 100% coverage of the area that we needed. And I think that we will have a very good looking surface model when we're finished. I think the engineer and the client are going to be very happy with it. And I think that we've got everything we needed. Yep. So I would consider it project success. Yeah, so overall going into the project, we knew it was going to be a great challenge with the terrain and the remoteness of the site itself. But after getting here, getting together with the team, Crafton Tull and Microdrones, developing a solid plan, we were able to overcome all those challenges in a short time, capture all the data that we needed for the designers and the client to push forward with the project. And the data that we've seen so far that we've processed looks really good, and I think everybody's going to be pretty satisfied. The Microdrones product and everything that they've built into the platform itself with the terrain follow, the planning functions in the software itself really helped us through this project and gave us an edge over some of the other UAVs we've used in the past.
We've been working with Matt for about 1.5 years now. Whenever we're on a project using their stuff, we feel like Microdrones is on that project with us. You know, if we ever need any kind of support or anything like that, it's just, I mean, they're right there.
Being able to see a project like this, where at the top of the mountain, you know, about 600 feet above the below part of the mountain, it's a lot of elevation change that would take a long time for somebody to survey. It keeps people off the mountain from having to survey it in the traditional sense, and we can gather much more data from the drone.
So now what we'll do is we'll pack everything up, wrap up everything here on site, take all the data back to the office and start processing it so we can get the deliverables ready for the client.
That's it. That's all she wrote.
From that project, or from what we saw, you know, there's a lot of things that went on in the background. And one thing I kind of wanted to speak on and have you guys kind of, touch on too, typically a typical workflow, you're going to plan a mission and upload it to the drone and let it fly. In this case, we just planned a block and sent the drone to the block. And once it got there, we just took it out of waypoint mode and held on to it. You know, flying it manually, one of the main reasons we were trying to do that, we chose to do that was because there's, we were right at the bluff with 150 feet of elevation change within about 100 foot wide area. So in this case, Jeff, you were able to, correct me if I'm wrong, you were able to kind of lower the elevation of the drone a little bit in certain areas to get more data on the actual bluff itself and make sure you're getting shots on the ground. Is that one of the main reasons why you were doing it that way?
Yeah, exactly. We knew, there were times, as I was standing on the bluff, the drone was actually almost at eye level with me or even below me a little bit as it was getting ground data kind of right there on the bottom side of the bluff.
Yeah.
And then as we kind of zigzag back and forth, I'd raise it up. We were able to capture the actual face of the bluff and get spray on that, and then raise it up, and then get some more kind of on the top of the bluff.
What'd you call it? You were just out there spraying lasers, right?
Right.
Spraying lasers.
The other thing that's not really shown, we actually had a kind of a moment of freaking out once we landed the system. If it's, we didn't really talk much about it in the video at this point, but that last flight, the wind was really starting to pick up. We're talking 15, 20 mile an hour sustained, kind of, I would say. I don't know exact, but it seemed like it, with some pretty heavy gusts while you were finishing that flight. But once you landed, what did we realize happened, Jeff?
So as before we made that flight on the bluff, we had removed the USB from the LiDAR payload to see what we had, and after we ran the data through POSPAC and dumped it into TBC, we forgot to put the USB back in the LiDAR payload, but luckily the engineers at Microdrones had the foresight to see this would be an issue. So once we threw the USB back in the LiDAR, it copied the data over, no problem. So we didn't have to make another flight or anything like that. So
it was Nick. Nick forgot to put it back in, right?
Yeah. See, I say we, but by we I meant Nick.
Yeah, that's what I thought.
It was actually it was in my laptop in my pocket. So I'll take responsibility for that one.
Yeah, we were freaking out, but we finally, you don't ever really want to test one of those. You want to test to make sure that works, but it definitely worked. It definitely transferred the data after the fact, and we didn't have to worry about reflying it, because it would have been even hairier, because that wind continued to get stronger throughout the day. Well, great. Well, I think, from here we can we can go into the data, and then from there we can kind of just start talking about everything, not only the data, but, really how we all got here, with NEI and Crafton Tull and Microdrones. And if you want to pull up the deliverables and whatnot, Nick, and go through that for us.
Yeah. So, just kind of to start the whole deliverable thing and kind of, how we got to this point. Just to speak a little bit about the relationship between Crafton Tull, Microdrones, and NEI, and the history of that. So we've been working obviously with NEI for years with our geospatial equipment, and about 18 months ago they approached us with this new UAV, this new drone system, and kind of pitched a new way of doing our actual survey workflow. And Crafton Tull, obviously, we stay on the leading edge of technology, so it intrigued us. Matt came along with NEI, did a live demonstration with the Microdrones UAV, and from that point, we immediately thought to ourselves, man, we've got to have this. It wasn't much longer, maybe 2 months, where we finally got the approval to delivery of the system, and and immediately started spraying lasers, as Jeff would say. All right, so for this particular project, what we were really tasked with doing was providing a surface model or a set of contours for an engineer. With the elevation change, the bluffs, some of the terrain issues, the actual owner of this land wanted to do an engineered design road instead of just hiring a bulldozer operator to clear a path, spread some gravel. They want to engineer some switchbacks, some drainage to make sure that there wasn't any issues in the future. And that's kind of what led us to actually flying the project. And so, what you're looking at right now, the finished deliverable, the finished surface model. And so you can kind of see this is color coded by elevation, with the red being some of the highest, the blue being the lowest, and then obviously you can see here in the middle, the actual bluff itself, and just kind of spin that to the side. You can really see the elevation change itself and what that actually looked like. And so kind of how we actually got to this point is we essentially we started with just a point cloud. So this is the first step. After we take it out of the Microdrone software and bring it into the actual Trimble Business Center, which is what we use for this project, we have 75 million points. And so you can kind of see, I'll change the view on this.
If you go into,
kind of really see the trees that the drone was able to collect, as well as kind of inside some of the lower vegetation, and as well as the ground. And so using the Trimble Business Center software, we ran this through a point cloud classification. And what we're able to do as a result of that is get it down to an actual ground model. So all these points are what we call bare earth. These points are all draped on the ground itself. And then from this, we're actually able to create the surface model. Just turn that off and so you can kind of see. And so this is the tangible deliverable that we actually give to the engineer itself. This deliverable carries all the weight and all the material that it needs to be able to design the road. You can actually kind of see right there where my cursor is, where there was kind of a natural washout, as well as right up here on the right-hand side, where the elevation change was very low. So this is the area that Randy had actually spotted out before we actually even got to the site, and then was our saving grace when he actually showed us this and showed the engineer this. And so the road was to come down this lower elevation, traverse this bench right here, and then switch back to get down to the lower portion and actually make it down to the valley. Okay, so I can see right here, we actually built a set of 2-foot contours on this project on top of that surface model. And you can kind of see how those just follow the earth and just kind of give us a really good perspective on what it's doing. As Jeff spoke to earlier in the video, we always get GPS check shots on the ground whenever we're doing our UAV. And those check shots, you can actually see them. Let me turn them on real quick. Here are the results of the actual GPS check shots that we took. We took 4 check shots, 1 at the top, a couple in the middle, and then 1 at the bottom. So you can see these are the results.
Has the client decided on what they're going to do? Or?
To be honest with you, I'm not sure that they've made it that far. So I know that the engineer was able to have enough information to design the road. The proposal was sent to the client for review with a proposed cost estimate, takeoffs, quantities of materials. And I think right now we are still waiting to hear back from the client on whether or not he wants to proceed into the construction phase.
Good deal. There's a lot of pieces that go into having successful end users like Crafton Tull. And, with Microdrones, we having a distributor like NEI Navigation Electronics and somebody like Ross Kinney be able to be that first line of support for Crafton Tull. I really would love for Ross to kind of share a little bit more about, NEI's role in Crafton Tull and their use of Microdrones, as well as all their other equipment, because the Microdrones equipment is just one small piece of what Crafton Tull does. And that relationship between NEI is crucial for both parties. Ross?
Certainly. First thing I want to say is from day one, since I started working for NEI, which is still a family-owned business by the Poche family, it was very clear to me, and it was made readily apparent that support of our clients is paramount. We always have to make sure that our clients are staying productive, and that really also comes down to the relationships that we form with these manufacturers. Obviously, the backbone of our business is we're a Trimble distributor. and Trimble, along with Microdrones, which is another distributor of ours, they have that same mindset. We want to put out great products, but in turn provide just as great support to our clients. So I guess from my perspective, it's definitely a focus of mine all the time is whenever our clients are in need, I'm there. I'm there to support them. And if it's not a need that's in the field and it's just something that I can provide them help with as far as other equipment, then I'm also going to help them to get what they need to keep staying productive on their jobs and on their projects. And I just think overall, to kind of speak to the industry as a whole, we're seeing a revolution now with these drones and this technology. The sensors that can be carried by these UAVs are getting smaller, but still even more robust. So I think the revolution we're seeing is very similar to what GPS did a couple of decades ago. And I think drones are going to continue to proliferate throughout this industry. And it's very exciting to see from my standpoint and hear success stories like Crafton Tulls and others. And I think there will be many more like it into the future as we continue into this new decade that I'm sure we're all very excited about.
For sure. Proliferate, huh?
Proliferate, that's right.
Do y'all have any final thoughts on the project, or and any benefits of using the UAV that you might not have missed on, or just kind of want to touch on real quick?
For the most part, it kept us off the mountain. That was the main benefit. I think we maybe talked about that. We were able to quickly and safely capture the data that we needed.
Keeping it off the mountain, I know we kind of talked on it a little bit, but staying off the mountain is a big deal. Actually trying to get in there and survey that, your GPS, especially if it was the middle of the spring, you wouldn't have been able to get very much GPS readings under that tree canopy with all those hardwoods, right? I mean, you probably would have, if it was in the middle of the spring, you probably would have had to use an instrument to actually survey that whole area. Am I wrong?
No, yeah, you're right. It probably would have been a lot of traversing.
And a lot of potential for mechanical injuries, whatnot. So
that's right.
And Nick, do you have any final thoughts?
Not really. I mean, overall, it was we knew it was going to be a challenging product, and with the help of NEI equipment, Microdrones support, we were able to get the project accomplished and get the data that we needed. So overall, it was project success, and we actually did it in a little bit less time than what I initially thought it would.
It was a learning experience for all of us. Being able to fly that project and deal with that terrain and deal with the elements of the terrain, like being able to ensure we were staying well within the FAA guidelines and keeping the drone within line of sight. That was the biggest hurdle we had. There was a point in one of the video shoots where Jeff is literally standing on the balcony of the lodge, peeking his head over, making sure he can see the drone. And he got it to the point where it was the last play he knew he could see it, and that's where we cut it. That was the second to last flight. When he brought it back, that's where you saw that final flight where we had to go fly it manually. We knew we were going to have to get through the woods in order to see the drone throughout the entire flight. So that was another good.
I mean, despite all the challenges and all the things that we went through and planning and the failed attempts at flights, the Microdrone squad was definitely the right choice for the job.
Well, everybody, I think that's it. So we, in closing, we really appreciate all three of y'all. Here at Microdrones, I can speak for the entire company. We cherish the relationships we have with Crafton Tull and with NEI. You guys are the backbone of one of the backbones of our companies, and being able to work with y'all on a project like this and see it come to fruition is great. So I'm excited for the public to see Down to Earth. I think it's really going to be a game changer for the geospatial industry to see a peek into how people are using not only UAV technology, but everything that goes into surveying and mapping, and all the nuance and everything from setting up the systems to getting your base station set up to getting to the project and hoping you know how to tackle it. Thank you, everybody, for joining us today. We really appreciate you spending the last hour with us here at Microdrones. If you have any more questions, please direct them to the link inside your GoToWebinar. You can actually submit a question there, and we'll get back to you as soon as possible. You will also be getting an email for a special offer, so if you'd like to take advantage of that, please do so. They will fill up fast, so we want to make sure we can get a system in your hands if you liked what you saw. And then finally, if you do have any more questions and you weren't able to submit them on the GoToMeeting link, please send them to Mason Styles, mason.styles@microdrones.com. Thanks, everybody. Have a great day.